So, self-driving cars, they're getting closer every single day. But they have this secret. To work safely, they all need to be constantly talking to each other. So how in the world do you test a communication network for thousands of cars without, causing the world's biggest traffic jam? Well, let's dive into the really ingenious solution researchers have come up with.
I mean, really think about that for a second. How can you possibly simulate thousands of autonomous vehicles all chatting at once to see if the network can even handle it? You can't just unleash them onto the highway. It would be total chaos, unbelievably expensive, and just incredibly risky.
And that right there is the core problem. As we get more and more autonomous vehicles, or AVs, testing their communication network becomes this massive hurdle. The cost, the risk, the sheer logistics of real-world testing are just way too high. Researchers needed a real breakthrough, a way to create a test track that perfectly blends the real world with a virtual one.
And that is exactly what they've built, a digital bridge. It's a brilliant idea that lets them plug one real piece of hardware, say a car's onboard computer, into a massive simulated world that's just jam-packed with thousands of virtual cars.
The technical name for this magic is hardware in the loop, or just HIL for short. It's this super powerful technique that's all about creating a hybrid reality for testing. You get the genuine, real-world performance from your actual device, but you can stress test it against a completely controllable virtual world. It's the best of both worlds.
Okay, so how does this digital bridge actually work? Let's take a look. On the far left and right, you see the real environment. That's our physical hardware. Right in the middle is the simulation. That's our huge virtual network. Now, the real key is that little blue box labeled Tap Interface. Think of it as a special gateway. It grabs the data from the real device and injects it straight into the simulation, basically tricking the hardware into thinking it's on a real road surrounded by thousands of other cars.
But, just building the bridge isn't quite enough. When you've got hundreds of virtual cars all sending data at once, you get a digital traffic jam. To solve that, the researchers introduced an AI, a smart traffic cop, whose whole job is to keep all that data flowing smoothly.
This AI uses a technique called reinforcement learning. And honestly, the easiest way to think about it is like training a puppy. The AI, which we call the agent, tries an action. If that action leads to a good result, like less network traffic, it gets a reward, a little digital treat. If it's a bad outcome, no treat. Over millions and millions of tries, it teaches itself the absolute best strategy to manage the network all on its own.
This diagram here shows that learning loop perfectly. Just follow the arrows. The agent on the right observes the environment. That's just the current state of the network. Then it takes an action to try and manage the data flow. If that action makes things better, it gets a reward. It's this simple cycle, observe, act, and learn, repeated millions of times, that makes this AI so incredibly smart. So we have the digital bridge, and we have the AI traffic cop. Now it's time for the real fun, putting the whole system through a virtual gauntlet to see if it can actually handle the pressure. And here you can see it all happening. On the left, we've got the real deal, a small robotic vehicle with all its sensors. It's sending its actual, real-time data through that digital bridge and right into the simulation that you see on the right. This is hardware in the loop, live and in action. Pretty cool, right?
Now, the testing was intense. They started simple, with a single vehicle baseline to see how it performed. Then they really cranked up the pressure, adding more and more simulated cars. After that, they ran the exact same tests, but this time they switched on the AI traffic cop to see what difference it made. And for the grand finale, they pushed it even harder, sending super high-def map data and even live video streams across the network.
Okay, this is the moment of truth. After all that setup, all that testing, did the digital bridge actually hold up? And maybe more importantly, was that AI traffic cop any good at its job?
The results are, well, they're fantastic. Just look at this chart showing network delay. That blue dashed line is the network without the AI. See how it just explodes when you get to 5 cars? The delay goes through the roof. But now, look at the green line. That's with the AI. It's so much more stable, controlled, and way lower, even as you add more and more cars. The difference is just night and day. And here's the killer stat. Right at that chaotic 5-vehicle mark, the AI slashed the data delay by over 51%. It literally cut the lag in half. That is a massive, massive improvement, and it's what ensures critical data gets where it needs to go, exactly when it needs to get there.
And it wasn't just about speed, it was about reliability. This chart shows how many critical LiDAR mapping messages actually made it through. Without the AI, you get about 100 messages. But turn the AI on,
That number jumps to 235. That's more than double the amount of crucial safety data getting through successfully.
So, let's just wrap this all up. The AI traffic cop was a huge success. It crushed delays and seriously boosted the amount of data that could get through, especially for critical things like LiDAR maps and video. What this all means is that this hardware-in-the-loop system is a total game changer. It makes developing the tech for our self-driving future faster, cheaper, and a whole lot safer.
It really makes you wonder, doesn't it? This is about so much more than just cars. This ability to seamlessly test real hardware inside these incredibly complex virtual worlds, well, it could accelerate development in robotics, in designing smart cities, and so much more. The digital bridge has been built, and it's pretty exciting to think about where it's going to lead us next.